Okay, and welcome to part 3 of your first lesson. So the first thing we're going to talk about right now is objects. So everything in Python is an object. Python, the way that we're using it, is something called an object-oriented language, which means everything that we run into in Python is an object. So I'm going to show you a little bit about what I mean here. So objects have an ID, so something to tell you like the unique identity of that object. They all have some attributes, stuff that you can, like things that are true about them in the same way that you might have like an age, that's an attribute that you have. Python objects will have different attributes. It will have 0 or more names, and then it will have a type. All right, let's see how that looks. Okay, so let's start Python, and we are going to create a variable a equals 7. Okay, so this is a variable that now exists in Python, and I told you that it's an object, and objects have an ID, so we can grab that using the ID function. So I'm going to say ID and then a, and it's going to print out this really long string of numbers that I am never going to remember, but this is the unique ID for the variable a. One other thing we can do with objects is ask Python what type it is. So for instance, I know this is an integer because I put an integer in it, but pretend I don't remember. I can ask Python type a, and it'll print out, oh, this is an integer or an int. Okay. So we just saw that objects have types, and we saw one of the type integer. But that is not the only type. First of all, I just want to point this out. You may not need to use this ever, but you can also write integers so we're writing them in base 10, like the normal way that we write numbers. You can also, if you need to, write them in octal, hex, or binary. If you do that, you're going to write a 0 and then either an X, O, or B, and then you can write your number. Okay, so other than integers, we can also have what we call floating point numbers. These are things that you might think are like decimals. They have not just whole numbers, but also decimal parts. So they have a whole number dot a part of a number. So we call them floats, and we can do all sorts of things with them. We basically treat them the same as regular numbers. So we're going to move on here. Okay, so another type that we have in Python is called a Boolean. And a Boolean is actually named after someone named George Boole, but it's just a true or a false value. So if something's true or false, it's a Boolean. However, we also, in Python, and you'll see this in a couple lectures, I believe, that true can also be represented by a 1 and false can be represented by a 0. Another type that we have in Python that we're going to use a lot, and actually already have used, is something called a string. And a string is what we would think of as like something that we would type out or something that we would say. When we printed Hello World in our first lecture, we were using a string. And the way that we tell Python something is a string is with quotation marks, either single or double quotes. But anything inside that, Python is going to think as a string. And a string is the first type that we will talk about that's a collection. So if you like write a sentence, that's essentially just like a collection of characters, a collection of letters. So it's one object, a string, that is made up of multiple little objects like characters. The second collection we're going to talk about, and second type of collection we're going to talk about, is a list. And a list is, a list, we tell Python something is in a list either by using the keyword list with parentheses or by using square brackets. So it's really important to remember square brackets means list in Python. Lists are really cool because we can actually have multiple types of data inside of it, and I'll show you what that means in a second. One other type that we're going to talk about is a dictionary, and dictionaries are also a collection. They have, it's one object made of multiple little objects, but instead of just storing them like in order, we store them with a name, or what we call in Python a key. So for instance, you might store someone's name, and the key is name, and then the value is their actual name. So mine would be name, and then the value would be Chelsea. One that we don't use quite as often, but is still pretty widely used in Python, is called a set. And a set is actually kind of like a list, but it only contains unique elements. So if we use a set, and in Python we do that by using curly brackets, it will only have each item once. So if you had like a list, say that was 1, 2, 3, and 2, if you turn that into a set, Python is going to get rid of that extra 2 because it's only unique elements. Okay, so let's take a little look at this. So for instance, we talked a little bit about strings. So one of the first things I'm going to do is show you a string. So I'm going to say hello. So this is a variable equals hello there. And I can set that equal, and I can say hello, and it's going to grab that string for me. Another type we talked about was a list. So I can say, okay, maybe I'm going to say the things that I had in my lunch. So I'm going to say lunch equals granola bar, water, apple, sandwich. Okay, so this is a list. I'm telling Python, because I have these square brackets, that this is a list. And I'm putting items in it. In this case, they're strings describing things that I had for lunch. In between each item, I put a little comma to tell it, okay, this is a new item. So I can go ahead and run that, and now I have a list that holds all the items in my lunch. Okay, so I can also make a dictionary, and I'm going to make a dictionary called me. And I'm going to set it equal to, and I'm going to say, okay, the first key is my name, and my name is Chelsea. Oops. And then I'm going to have a second thing, and I'm going to say height, and I don't really want to calculate my height. I think it's 75 inches. And so I'm going to go ahead and do that. And now I have a dictionary that has keys for my name and my height, and then the values are my name and approximately my height if I did the math in my head correctly. Okay, so I just really quickly want to show you that set thing. So I'm going to make a list. I'm going to call this list A. It's going to equal to 1, 2, 3, 2. So when I look at A, Python knows that A contains items 1, 2, 3, and then 2 again. If I turn that into a set, it gets rid of that extra 2. So see, I had 1, 2, 3, 2, and then I turned it into a set. Python goes through and looks for all the unique elements in that set. Okay, so one really cool thing about Python is that objects can change. So for instance, one thing that we can do is I can say, okay, well, I'm going to have this thing called A, and what is that? Well, right now it is a list of the numbers 1, 2, 3, and 2. Okay, now I can just double check. I can see that that's a list, but we can double check. We can say type A, it's a list, just like we thought. But I can also say A equals 9. Now when I ask Python what A is, it says 9. And I can ask it, okay, well, what's the type of A now? It says it's an integer. So different objects can change what their types are. So I first started it off as a list, and then I changed it to an integer. One thing I can also do, let's put this to the string 1.5. So when I ask Python what the type of A is, it's going to say, well, it's a string. But I say, oh, like, I know it's a string, there's quotes and everything, but I want that to be an integer, or actually, excuse me, a float. So what I can do is I can say a equals float a. And remember, a float is just what Python calls like a decimal, a number with decimals. So when I do that, I can print out a, oh, now it's a float number, and we can double check that by saying type a, oh, it turned itself into a float. So different objects can change their types, but not always. So let's have a variable called b and set it equal, oh, well, I pressed enter too. I set it equal to the string Eric idle. And I'm going to say, oh, well, I want b to be a float. So I'm going to do the same thing we did with a, b equals float b. And Python is going to say, what are you talking about? That is not something that I can turn into a floating point number because it's just a string. In fact, it's the name of a man from Monty Python. And it's going to say, no, I can't do that. Okay, so the next thing we're going to talk about is operators. And operators are those symbols that actually probably look like math symbols that you've already seen. So things like pluses and minuses and multiplication. Let's talk a little bit about those. Okay, so let's go ahead and try and use operators in the way that we think we normally would, like by using Python as a calculator. So I want to know what 1 plus 17 is. Well, Python is going to output 18, and that makes sense to us. That's what we normally think that a plus sign would do. But what happens when we add two things that aren't numbers? How about hello plus goodbye? So before we run this, what do we think is going to happen here? When we added two things before, they were integers, and we just added them the way that we normally would add integers. But now we're adding two strings. So when we run this, okay, so what outputted was a string that had both the first string and the second string in it. So now we have one long string that says hello, goodbye. So operators do different things depending on the type of the variable or the type of the object that you use them with. We saw that with integers, or actually with any number, I can show you it's 7.5 plus 1.4. If it's with a number, it's going to add it the way that we think of adding. If it's with a string, it's going to do something called concatenation, where it puts them together. It takes one string and kind of glues the other string on. And that kind of makes sense. You say, okay, like I want this one string and I want to, add this other string. Concatenation makes sense in this case. But we have to remember that those are kind of two different things. The plus sign operator is doing two things depending on if it's a number or if it's a string. Okay, so then we also want to talk about constructors, which we actually used just a little bit ago. So these are functions that take an object and create it change it to be the type of that constructor. So to change something into a string, we can use the string constructor. So let's see how that might work. So I have a variable called k, and I'm going to set it equal to 10. But I say, oh, I'm actually going to put this number in a sentence, so I want it to be a string. So I'm going to say string or strk. And what outputs is the number 10 as a string. And we can actually do this for all different kinds of types, and we actually already did this when we turned something into a float earlier. So we have string, we have int, we have floats, we have lists, and we have dict for dictionary. Okay, so let's talk a little bit more about operators. Okay, so I'm going to make this a little bit bigger. The first operator that we're going to talk about is one that we have already talked about, the plus sign operator. So remember, we know that we can add two integers together, we can add two floats together, we can even add two strings together. I'm going to put a space in. Okay, but there are other operators. So for instance, we could do a minus. So let's do 10, minus 8. and Python will output 2 for you. Then we have the multiplication operator, so we'll do maybe 17 times 21. And this asterisk tells Python, multiply these two things. And then we also have some operators that may not look exactly the way that you think they would. So we also have the to the power of operator. So if we do 2 to the power of with 2 stars, 4, it's going to tell us that that's 16 because 2 to the power of 4 is 16. So we're going to call that the exponent operator. And then we also have division, which you probably are familiar with. So one thing we could do is we could say, what is 10 divided by 3? Okay, well that is 3.3333333, and so on. However, we also have a different kind of division in Python. So what we do is we have 2 of those slashes, so 10 divided by 3. And that outputs just the number 3. So what's happening here is something called floor division. And essentially this tells us how many times the second number goes into the first number evenly. If you remember doing like long division by hand, you'd remember like, oh, we'll find how many times something goes into another number evenly and then there's like a remainder. Well, this is kind of doing that. So if we did like 100 divided by 6, we would get that 6 goes into 100 evenly 16 times, and then there's probably some remainder left over. So one division, or like one slash, is the division that we think of. It's like normal division. 2 slashes is floor division, which gives us how many times one number goes into the other evenly. And then to get that remainder, we're going to use an operator that you may not have seen before called the modulo operator. And the modulo operator looks like this, just like a percent sign. So if I said 100 modulo 6, it's going to tell me the remainder. So it says when you take 6, or when you divide 100 by 6, there's a remainder of 4. So 6 goes into 100 16 times with a remainder of 4. So I just want to show you something really cool, something that we might work with soon. So 10 is an even number, right? That means that when we say 10 modulo 2, what should the answer be? 0, right? Because 2 goes into 10 evenly. That's part of being an even number. We can do 12 modulo 2. We can do 20 modulo 2. All of these have a remainder of 0 because 2 goes into them evenly. But what if I have an odd number like 31? So I say 31 modulo 2. Okay, well, that has a remainder of 1. So one way that we can tell that things are even numbers or odd numbers is whether they have or don't have a remainder of 0 when we use the modulo 2 operator. So when we say an odd number modulo 2, we're going to get not a 0. When we do an even number modulo 2, we get a 0. So one other thing I want to talk about is mixing floats and ints. So remember, floats are numbers that have decimals, integers are just like whole numbers. So when we do some operations, and let me go over here, say we do 10 divided by 3, or actually we'll do, 10 times 3, and we know that should be 30, right? So we can even do A equals 10 times 3 because we want that for some reason, and we can say type A, and it's an integer. Well, what if we did the same thing, but we said A equals 10.0 times 3? Now, actually, let's just print it out first. You can see that instead of an integer that doesn't have a decimal value, we have a float. Even though there is no like decimal part, like they're all zeros, this is still a floating point number because it contains information about the decimal. And we can even just double check. We can say type A. Oh, it's a float. Okay, so what's happening here is when Python does operations with floats and integers, it is going to usually default the answer to be a float. And the reason why it does this is because floats have more information than an integer. If you have the number like 10.27 and you turn that into an integer, Python is going to convert that number into 10. So you've just lost a little bit of information, right? You lost that 0.27. And so Python is going to default to floats because it has just a little bit more information. So if you mix them, your output is going to be a float. The exception to that actually though is those divisions. So remember we talked about the difference between a regular division and a floor division, which has those 2 slashes. Normal division will always make floats. Floor division with those 2 signs is always going to make integers. That's just something that is written into the way that Python works. Okay, so we're going to next talk about the order of operations, something that you've probably heard about in some of your math classes. It is called precedence in computer science if you really want to be fancy about it. And order of operations just means which operations that Python is going to do first if there's multiple operations in one line. So just like in math, it's going to do anything in parentheses first, then it's going to look for exponents, then it's going to look for positives and negatives. So these aren't addition and subtraction. This is like if a number is positive or a number is negative. Then it's going to do multiplication and division. But unlike in regular math, we have multiplication, the asterisks, division, and then we also have modulo and floor division, which count on the same level as multiplication and division. And then we go to addition and subtraction. And remember, if there's more than one of these, Python will always do them from left to right. So far, this is just like in math class. So for instance, in this first line, 2 plus 3 times 5, Python is going to look at it and it's going to go, okay, well, the first thing I want to do is this multiplication, so it's going to do 3 times 5, and then it's going to see, oh, there's an addition here, so I'm going to do 2 plus whatever 3 times 5 was, which is 15, so you get the answer of 17. In this next line, we have 2 plus 3 inside parentheses, so that's the first thing that Python's going to do, so it's going to add 2 plus 3, which is 5. And then it's going to multiply it by 5. So we get 5 times 5 equals 25. Okay, on this line, we have 3 operations. We have an exponent, we have a multiplication, and we have an addition. So we're going to go ahead and do that exponent first. So 5 squared is 25, times 3 is 75, and plus 2 is 77. So we did exponent first, then multiplication, and then addition. Okay, so we're going to talk about some operations which are really just shortcuts for you in Python. So if we ever want to add a variable or add a number to a variable, so for instance, I might say like, okay, well, every time I run this program, add 1 to the variable a. So I can do that in a really long way. I can do that, and actually I'll show you here. So I can say a equals 0. Okay, so I can say, okay, I want a to be equal to whatever a was plus 1. So I want to add 1 to the value of a. I can say a equals a plus 1. Okay, so now we can see a equals 1. I can do it again. A equals a plus 1. And now a equals 2. So I'm just incrementing my variable. However, there's an easier way to do this because this is actually something we do in Python quite a lot. I can say a plus equals 1. And this is just a shortcut that tells Python that I want to take a and add 1 to its value. So it's basically the same thing as this line. It's saying a equals a, whatever its value was, plus 1. So when I run that, I can see a now equals 3. And I can actually do this with all of our common operators. So I can say a minus equals 1. And when I say a, okay, now it equals 2. So it took a and it subtracted 1. So this a minus equals 1 is the same thing as a equals a minus 1. I can also do this with multiply. So let's just check the value of a. So a equals 1. So I can say, let's actually add 1 so we can actually tell that it does a multiplication. Okay, so a now equals 2. So I can say a times equals 5. So it'll take whatever the value of a is, multiply it by 5, and store that all back in a. So I can see, oh, okay, now a is equal to 10. Remember, this is the same thing as saying a equals a times 5. And I did it again, so now a equals equal to 50. And I can also do this with a division sign. So I can say a divided equals 5, and now a is equal to 10. So these are just shortcuts. These are things that make your life easier, make my life easier reading your code. But again, remember they're the same as saying a equals a, the operation, and then whatever value is on that side. Okay, that is the end of this video. We will join next time to talk about math.